is either male or female. So it's going to be all students to be C. Okay, moving on to the probability of an event. Okay, probability of an event A measures how often we think A will occur. Okay, so that's why we define a probability to the function of A, right? So this is how we define the probability of A. Let's say the event is B, so it's going to be B. C is going to be C. So it depends on how you define the event. And suppose that an experiment is performed 9 times, the relative frequency of an event N is, so we define as number of times A occurs divided by N. So the probability is defined as F per N. Okay, proceed with the probability of an event. The probability of A must be between 0 and 1 if event A can never occur. So P probability of A is 0 if event A always occurs. So it means that the probability is 1. The sum of the probabilities for all simple events in S equals to 1. And the probability of an event is found by adding the probabilities of all the simple events in A. Okay, for example, right, and the experiment toss a dice. Let's say you want to observe an odd number. So there are 3 out of 6. So it's going to be halved. And for the events B, to observe a number greater than 2, so it's going to be, of course, 4 out of 6, so it's going to be 2/3. If let's say the event is to observe a 6, so it's going to be only 1 out of 6. So so that's why it means here, right, the N is, for example, right, this is the end. So the 6 is the N, which is the, it's performed, I mean the experiment is performed like N times. So in this case we have 6 surface, so like 6 times, because you toss a dice. Okay, exercise 1. Toss a fair coin twice. Alright, a fair coin twice. Okay, you know, right? A simple normal coin. Toss it. What is the probability of observing at least one head? Okay. Okay, so this is the head. No head. Head and tail, right? If let's say there's a head and there's a tail. First coin. Head and head. Okay, so the P, the probability of at least one head is E1, E2, and E3. You say that E1, E2, E3, because this one there's no probability to observe at least one head, right? Because you mentioned here at least one head. So there's one head, one head, one head. There is no head here because it's TT. So basically this is something that you learned during your SPM, I believe that. Okay, moving on to the next exercise. A bowl contains 3 M&Ms, one red, one blue, and one green. A child selects 2 M&Ms at random. What is the probability that at least one is red? Okay, as usual, you have to. This is the normal practice for you to come out, right? Because actually, from this kind of practice, you can learn and you can understand better about probability. So you have to make the structure like this: M to be M and M. M is the color, right? So the color is blue, green. All right, so this is the probability. So it's going to be 1/6 because there's so many. Okay, there's 6 times. So how many red? All right. Any guesses? 1, 2, 3, 4. So there are four red, right? So this is the probability of at least one red. Counting rules. So basically, we are fortunate because there are several counting rules that can be applied in order to calculate the total number of event occurrence, named as the MN rules. It is also called permutation and combinations. But remember, counting rules are not the probability, but counting rules can be used to reduce the probability. Okay, so the MN rule. If experiment is performed in 2 stages with M ways to accomplish the first stage and N ways to accomplish the second stage, then there are MN ways to accomplish the experiment. This rule is easily extended to case stages with the number of ways equals to N1, N2, N3, and Nk. Example, toss 2 coins. The total number of simple events is toss 2 coins. Of course, right? Only head and tail. So it's only 2. Toss 3 coins. The total number of simple events is 3 times, 2 times 2 times 2 is going to be 8. Example, toss 2 dice. The total number of simple events is, so it's going to be 6 times 6 because there are 6 surfaces of dice. Permutations. Okay, what is the difference? In English, we use the word combination loosely without thinking if the order of the things is important. In other words, my fruit salad is a combination of apples, grapes, and bananas. We don't care what order the fruits are in. They could also be bananas, grapes, and apples, or even it could be grapes, apples, and bananas in the same fruit salad. In the meantime, the combination to the saved is 472. Now, we do care about the order. 724 won't work, nor will 247. It has to be exactly 472. So in mathematics, we use more accurate language. If the order doesn't matter, it is a combination. If the order does matter, it is a permutation. So you have to take note on this term in statistics. Alright, so we should really call this a permutation log. In other words, a permutation is an ordered combination. Okay, permutation with repetition. These are the easiest to calculate. When we have n things to choose from, we have n choices each time. When choosing r of them, the permutations are n times r times. In other words, there are n possibilities for the first choice, then there are n possibilities for the second choice, and so on, multiplying each time, which is easy to write down using an exponent of r, which is n to the power of r. So in this case, permutation with repetition is the number of ways you can arrange, and n objects taking them r at a time is n to the power of r, as previously mentioned. So for example, right, how many 3-digit log permutation with repetition can we make from the numbers 1, 2, 3, and 4? Okay, so easy. So it's going to be n and the r, which is r is the taking them at a time. So like 3 times, right? 3 digit, and the numbers are 4. So the total, the total log permutation that you make from this 3 digit is 64, because 4 to the power of 3. Okay, next up is permutation without repetition. In this case, we have to reduce the number of available choices each time. Without repetition, our choices get reduced each time. But how do we write them mathematically? answer, we use the factorial function. So the factor function, the symbol is exclamation mark, just means to multiply a series of descending natural numbers. For example, for factor function, mean to say that 4 times 3, 4 times 2 times 1, not times. Yes, yeah. So yeah, it's the same, right? Times and multiply. Okay, 4 multiplied by 5, by 3, by 2, by 1 equals to 24. And also 7, 7 factorial function. 7 multiplied by 6, 5, 4, 3, 2, 1 equals to 5040. And 1 factor function equals to 1. Note, it is generally agreed that 0 factor function is 1. It may seem funny that multiplying no numbers together get us 1, but it helps simplify a lot of equations. So please take note that 0 factorial function is equals to 1. So for the permutation without reputation, the number of ways you can arrange n distinct objects taking them r at a time is p. The permutation equals to n as factor functions divided by n minus r factor functions. Mean to say that if n equals to n minus 1 and minus 2. Okay, so these are example, right? How many 3-digit log permutation can we make from the numbers 1, 2, 3, and 4? So the order of the choice is really important in this case, as we know that the number is 4. Okay, just now it's also 4, right? So the n is 4, and the divided by is n, which is 4 minus 3. So this is the answer for factor functions per 1 factor function. We just see that 4 times 3 times 2 times 1 equals to 24. Okay, exercise 5. A log consists of 5 parts and can be assembled in any order. A quality control engineer wants to test each order for efficiency of assembly. How many orders are there? So 5 orders, right? Because there are 5 parts. And it can be assembled in any order, so which is 0. So equals to 1 to 0. So the combinations is the number of distinct combination of n distinct objects that can be formed, taking them r at a time is c. Combination equals to n factorial per r factorial bracket n minus r factorial. Okay, for example, 3 members of a 5-person committee must be chosen to form a subcommittee. How many different subcommittees could be formed? Okay, the order of the choice is not that important, so in this case 5% is 5, right? 5 number, and 3. Okay, 5 factorial, so it's going to be 5, 4, 3 times 2 times 1 equals to and then 3 so it could be any number, because the order of choice is not that important.